Hello, and welcome to the videos for solving linear equations. This is the first of two videos that will be on this topic. So first, let's recall from last lesson when we were talking about linear expressions. What do we have there? Well, we had variables, which was an unknown quantity, and we used either letters or symbols to represent that quantity. And then a linear expression, and that was just simply a combination of the mathematical statement that performed operations of math: addition, subtraction, multiplication, and or division. So it was just statements. We weren't trying to find what did the value equal. We weren't performing any operations to move pieces around. Essentially what we were doing, distributing and combining like terms. That was the basis of what we were doing. We're now going to be solving the equations. So let's look at a definition. So the definition for a linear equation, and we see, what are the first four letters here? EQUA. And that's similar to what? Equal. And all it's doing is taking a linear expression, putting an equal sign to where we now need to solve to find out what the variable would actually equal to make it a true statement. So we have the definition that a linear equation is a mathematical statement mathematical expression that contains an equal sign and a linear expression. So again, from last lesson, we might have had what? We might have had something that looked like 3x minus 2. This is a linear expression. It has some numbers. It has a variable. It has a subtraction sign. The difference now, though, so this is as far as we go. We simplified it. That's it. But now the linear equation puts an equal sign there, sets it equal to some value, so that now there's potentially a very specific value of x that would make this true. A couple of restrictions that we have, though. So we can't just write anything we want and call it a linear equation just because we put an equal sign there. So we have the following restrictions. The following cannot occur in a linear expression. So first, if we look at this linear expression that we wrote, turned it into an equation, the exponent on the x is what? It's a 1. And that's all that it can ever be. If it's anything besides 1, it's not a linear expression. So the first one is that no exponents other than 1 on the variable. Number 2, we cannot have roots. So no square root, no cube root, anything like that. So no roots on the variables or variable. And then lastly, third, the variable cannot be, well, the variables cannot be multiplied by each other. So for example, I couldn't have x times x plus 1 equals 0. If I distribute, like we learned in the last lesson, I would have what? X times x, this is our exponents, turns into x squared, so we violate rule number 1. So I'm not allowed to have that. I can't have variables multiplying each other. So, I told you, all right, we can potentially solve this to find out what the value of x could equal to make it true. What do we do for that? What are the steps? And again, all semester, I keep stressing to you guys, what is the process? What are the steps that we need to do for the problem? So I haven't written any numbers up here yet saying, okay, solve this and here's what you have to do. No, I'm going to give you the steps. And if you follow these steps through every single linear equation problem, it will get you to your final answer. So first, we want to simplify both sides if necessary. And this is usually one of two things. I alluded to it a little earlier, which is what? Either distribute or combine like terms. And it could be both of these. We might have to distribute a number in front of a parenthesis and then combine like terms after that. Step 2. Move the variables to one side constants, or our number, to the other. Once we get done with step 2, we should have all the variable pieces on one side, let's say the left side. Any numbers will be on the right side. Once we do that, once we have isolated the variable, then we can divide the coefficient. And remember, what is coefficient? We talked about this last time. It's the number that's in front of the variable. So whatever number we have left in front of the variable, let's say on the left side, divide by that coefficient to get the variable by itself. And that will give us the solution. Now, step 4. Do you have to do step 4? Not really. I mean, you've done what you need to do here. You're solving a linear equation. After step 3, you have it. You have potentially what the answer is. However, step 4 is check your answer. So if this is an exam, and I tell you, all right, solve this linear equation, and you go through all the steps, and you tell me, okay, George, the answer is x equals 5. Well, is it for sure? Obviously, when I hand the test back, you'll know if it's right or not. But before you ever turn in the exam, you'll know if it's right. Check your answer, plug it back into the original equation, and if it makes both sides equal, then you know you have the right answer. You can come up, turn in the exam, say, George, just give me 100 because I checked all my answers and I know that they work. Probably not going to give you 100, but I'll be more than happy to give you 100 after I check it and see that, yes, in fact, you checked your work and everything balances out. So let's look at some examples. If you're still writing, go ahead and hit pause, get caught up with the writing there. Otherwise, our first one. We want to solve for x. And we're given 4x is equal to 12. So again, it's going to be the normal process we do. We're crawling, then we'll walk, then we'll jog, then we'll run. This is crawling here. This is as basic as we can get for a linear equation. Number 1, simplify both sides. We don't really need to, right? It's already simplified. We don't have to distribute anything. We don't have to combine like terms. Number 2, move variables to one side, constants to the other. Again, it's already done for us. The x variable is on the left side. The constant, the 12, is on the right. So we move down to step 3, which is divide the coefficient. divide the coefficient, did I write that down? Yeah, divide by the coefficient to get the variable by itself. So, the coefficient is what? The coefficient is 4. So I need to do this to both sides. Think of it like a teeter-totter or a seesaw, depending on how old you are. I don't even know if they have them on the playgrounds anymore. But if we do something to one side of the teeter-totter, it's going to do what? It's going to put it out of balance. So if I do the same thing to the other side, it brings it back into balance. It's where I started at. So same thing here. If I divide the left side by 4, the only way that I can keep this thing equal to what I started with is by dividing the other side by 4. So when I do this, the 4's cancel out, give me 1 and 1. So I get what? 1x. And we don't write the 1 as we talked about last time. It's that invisible 1 that we're going to see throughout math here. So it's just telling me x is equal to 12 divided by 4. That's 3. You're saying, okay, I'm done. The answer is 3. Is it? Maybe, but let's check. And how do we do that? We take this and we put it back in the original. And the original said 4 times x, and if I'm saying that that's 3, then this guy should balance out. The left side should equal the right. Well, 4 times 3 is 12. 12 does equal 12, so now I'm 100% sure that x equals 3 is the answer for this problem. All right, number 2. And again, if something you got stopped along the way doesn't make sense, go ahead and hit pause, go ahead and hit rewind. Otherwise, we'll move on to the next problem here. So again, this one is solve for x. And we have 2x minus 6 is equal to 0. So step 1, simplify both sides. It kind of is. There's no distribution. There's no like terms to combine. So I need to move the variables to one side, constants to the other. So if I leave the x part on the left, I want to get rid of the negative 6. I want to move it over to the right side. Well, how can I do that? I'm going to take the opposite of it. So I have negative 6. I want to add 6. And again, it's kind of like our teeter-totter here, or seesaw. So I'm going to add 6 on the left. I need to add 6 on the right. So what happens? These 6's cancel out, so all I'm left with is 2x on the left-hand side. And then here, 0 plus 6 is just 6. Now, step 3, divide by the coefficient. Our coefficient is 2, so I divide by 2. Cancels out. X is equal to 6 divided by 2 is 3. So now you're saying to yourself, aha, I see a pattern. The answer is always 3. No, it is not. It just so happened that in both of these problems, the answer was 3. But I guarantee you the answer is not always going to be 3. So do the work, do the steps, do your calculations. Again, we can check our answer. If we plug it back in, we want to know is 2 times 3 minus 6, does that equal 0? Well, 6 minus 6 is 0, so yes, 0 equals 0. So once again, I can be 100% sure that x equals 3 is the answer to this linear equation. Again, if you need to kind of go back through it, feel free. Otherwise, we'll move on to example 3 here. So we had crawl, we had walk. Now let's try to jog a little bit here. Again, solve for x. We have 3x plus 4 is equal to 4x minus 3. First thing we have to do, simplify if need be. We don't have to in this case. So move the variables to one side, constants to the other. In this situation, I have both. I have variables on both sides. I have constants on both sides. So I'm going to have to move them each separately. So if I deal with the variable piece first, if I want to move the 4x over to the left, it means what? It means I have to subtract 4x on the right. That way 4x minus 4x, these cancel out. But the only way I can do that is if I do the same thing on the left side. So 3x minus 4x. 3 minus 4 is negative 1. So I end up with negative x as my variable. Don't forget to bring this guy down, so plus 4 is equal to, again, these cancel out, so the only thing I have left on the right side is the negative 3. Now move the number piece. So I want to move it from the left over to the right. I have to do the opposite, so I have plus 4, meaning I need to minus 4. So these cancel out. I'm left with just negative x on the left side. Negative 3 minus 4 is negative 7. So what do we see here? We've got a ton of negative signs in this problem. And I tell you guys all the time, when you get negative signs, slow down. Be careful with your work, because that's where a lot of the dumb mistakes are going to come in when you have to start dealing with these negative signs. So this is not my final answer. I want to solve for x. I don't want to solve for negative x. You wouldn't tell somebody, oh, negative x equals negative 7. It's like, no, what is x equal to? So to do that, again, remember there's this invisible 1 here. So I divide both sides by negative 1. Negatives cancel out. I'm just left with x on the left. Negative 7 divided by negative 1. Negative divided by negative is positive. 7 divided by 1 is 7. Again, I'm not going to keep checking all these. Interest of time, you don't need me to see me do that. But if you're working these problems on your homework, especially on an exam, go ahead and check them, make sure you have it right. All right, the last one here. This will wrap up video number 1. So the fourth example is solve for y. Wait a minute, y? I thought variables were x. No, variables can be anything. X, y, z, w, u. It can be symbols, alpha and beta. So don't get locked in that, oh, if it's not an x, I can't solve it. You can, it's just a different unknown piece that we're looking for. So on this one, we have 2 times y plus 1 is equal to 3 times 1 minus y. So here's my suggestion. We've only done a few of them, but if you're getting the hang of it, hit pause. Try to work this out. If you can figure it out, great. If not, if you get stuck, hit play. Let me catch up with you, try to get you through where you're stuck. Otherwise, if you want to follow through, that's fine as well. So we're going to do what? Step 1, we need to simplify both sides. I need to distribute the 2 on the left. I need to distribute the 3 on the right. We have a negative, so be careful. On the left, when we distribute, we get what? 2y plus 1. See there? 2y plus 2. 2 times y is 2y. 2 times 1 is 2. On the left, 3 times 1 is 3. 3 times negative y, so again, this is like a negative 1 here. 3 times negative 1 is negative 3. So the right side becomes 3 minus 3y. So be careful with those negatives. And again, we need to move the pieces. So let's move our variable piece first. Because I have a minus 3y, again, I have to do the opposite. I need to add 3y to both sides. That way these guys will cancel each other out. So on the left, I get 2y plus 3y is 5y plus 2 is equal to, the only thing left on the right side now is our value 3. Move the 2. So again, it's the opposite. I need to subtract 2 from both sides. So I get 5y, 3 minus 2 is 1. So now I've completed step 2. I have the variables on one side. I have the numbers on the right. So divide by the coefficient. The coefficient is 5. So I get what? Y equals 1/5. Well, wait a minute. I must have done something wrong. That's not a nice number. It's not a nice number. That happens. More often than not, to be honest with you, you're probably going to get answers that aren't nice numbers. We don't live in a world where everything is always a nice number. So that's okay. We just have a fraction as an answer, but it's still the potential answer. And again, we could check it. We could plug it back in, do our fraction math, see if it works out. But again, point of this problem, to show you. You might not always end up with a nice answer, and that's okay. So that wraps up video number 1. Kind of some straightforward examples. Come on back for video 2. We'll talk about different types of solutions you can get, and then also one final scenario that you may be faced with and how you would solve that. So we'll see you guys in video 2.